Somewhere beneath your fingertips right now, an invisible drama is unfolding. Your skin rests against a surface, perhaps a blanket, perhaps a chair, perhaps the glowing device beside your bed. Feels solid, stable, certain, but deep beneath the world your senses were designed to understand, something astonishing is happening. The atoms inside your body are not truly touching the atoms around them at all. In fact, according to everything modern physics has discovered, nothing in the universe has ever physically touched anything else. Not once, not ever. Tonight, here on Velerin's Sleepy Space Mysteries, we are going to descend slowly into one of the strangest truths ever uncovered by science. A truth hidden inside atoms, hidden inside electrons, hidden inside the quiet architecture of reality itself. And if tonight's mystery draws you in, you may also enjoy our journey into the strange silence between stars, where even empty space may not truly be empty at all. Because the deeper physics looks into the universe, the more the familiar world begins to dissolve into something dreamlike and almost impossible to picture clearly. Before we continue, take a quiet moment to subscribe, leave a like, turn on notifications, and perhaps even join the channel membership if you enjoy these slow cosmic explorations. And somewhere out there in the darkness tonight, tell us where you are watching from. There is something comforting about imagining distant listeners scattered across the sleeping earth beneath the same sky. For thousands of years, human beings believed matter was simple, solid, permanent. Ancient philosophers imagined tiny, indivisible particles like grains of cosmic sand. Later generations pictured atoms as miniature solar systems with electrons circling nuclei like planets orbiting stars. It sounded elegant, predictable, comfortable, but nature turned out to be far stranger than human intuition ever expected. The electron, the tiny entity responsible for chemistry, electricity, light, and nearly every physical sensation you have ever experienced, is not actually a tiny object in the ordinary sense. It does not possess a clear surface. It does not travel through space like a microscopic marble. Sometimes it behaves like a particle, sometimes like a wave, sometimes like a cloud of probability spread across multiple possibilities at once. And from this strange behavior emerges the illusion of solidity itself. The chair beneath you, the walls around you, your own hands resting softly in the dark. All of them are mostly empty space held together by invisible fields and quantum rules operating far beyond ordinary perception. The deeper scientists looked into matter during the 20th century, the less physical reality resembled the world our senses evolved to perceive. Atoms became ghostly structures of probability. Electrons became vibrations in invisible quantum fields. Even touch itself began to lose meaning, because what feels like contact is actually resistance. Electromagnetic fields pushing against one another. Quantum laws preventing particles from occupying the same state. Tiny invisible barriers that create the sensation your brain interprets as touch. You have lived your entire life inside this illusion without ever noticing it. Every hug, every footstep, every raindrop against your skin, every page turned by your fingers. None of them involved actual physical contact in the classical sense humans once imagined. And perhaps the strangest part is this. Despite how alien this sounds, it is not speculation. It is among the most experimentally verified knowledge humanity has ever discovered. The equations describing these invisible interactions predict reality with astonishing precision, more accurately than almost any other scientific theory ever created. Tonight we begin at the edge of that mystery. We will move carefully downward through atoms, through electron clouds, through quantum mechanics, through the hidden architecture of matter itself. And somewhere along the way, the ordinary world may begin to feel wonderfully unfamiliar. The universe is often far stranger than science fiction, not because reality is magical, but because reality does not care whether human intuition finds it comfortable. And as the night deepens around us, we will discover that the solid world has always been something softer, stranger, and more ghost-like than it first appears. For most of human history, the atom was imagined as the final layer of reality, a tiny indivisible grain hidden beneath all visible matter. The word atom itself comes from the ancient Greek atomos, meaning uncuttable. Philosophers imagined that if you kept dividing matter into smaller and smaller pieces, eventually you would arrive at a final fundamental particle beyond which nothing smaller could exist. It was a beautiful idea, simple, elegant, comforting, but the universe rarely chooses simplicity when something stranger is possible. By the late 19th century, scientists had begun uncovering evidence that atoms were not indivisible at all. Electricity itself hinted at hidden internal structure. Strange glowing beams inside vacuum tubes suggested that something smaller than atoms might exist. Then, in 1897, a physicist named Joseph John Thomson shattered the ancient picture forever. Working with cathode ray tubes, he discovered tiny negatively charged entities streaming through the vacuum. These particles were far smaller than even the lightest atom. Thomson had discovered the electron. Suddenly, the atom was no longer fundamental, contained hidden architecture, hidden motion, hidden mystery. At first, scientists imagined electrons as tiny balls embedded inside a positively charged sphere like raisins inside pudding. Sounds almost charming now. But science was only beginning its descent into quantum strangeness. In 1911, Ernest Rutherford performed one of the most famous experiments in physics. He fired positively charged alpha particles at an impossibly thin sheet of gold foil. According to existing models, the particles should have passed through with only minor deflections. Most did, but some bounced backward at enormous angles as though they had struck something unexpectedly dense and powerful hidden inside the atom. Rutherford realized the atom must contain a tiny central nucleus carrying nearly all its mass. The rest of the atom was almost entirely empty space. This discovery changed humanity's understanding of matter forever. Imagine enlarging a hydrogen atom until its nucleus became the size of a marble sitting at the center of a vast cathedral. The electron would orbit somewhere near the outer walls. Everything in between would be empty. Not empty in the ordinary sense perhaps, but empty of solid matter. The realization was deeply unsettling. The physical world felt solid and continuous to human senses. Yet beneath that illusion, matter was mostly void. Then came an even deeper problem. According to classical physics, electrons orbiting a nucleus should continuously lose energy by emitting electromagnetic radiation. They should spiral inward and collapse into the nucleus almost instantly. If classical physics were correct, atoms could not exist. Matter itself would be unstable. Yet the universe clearly existed. Stars burned. Planets formed. Human beings sat quietly beneath night skies wondering about reality. Something in the old understanding had failed completely. In 1913, Niels Bohr proposed a radical idea. Electrons could occupy only certain allowed energy levels around the nucleus. They could jump between these levels by absorbing or releasing specific packets of light called quanta. This explained why atoms emitted precise colors of light. It also prevented electrons from collapsing into nuclei. The atom survived because quantum rules restricted what electrons were allowed to do. Yet even Bohr's model remained incomplete. It still imagined electrons as tiny particles moving along definite paths like miniature planets. The deeper truth had not yet revealed itself. Then, during the 1920s, reality became stranger than almost anyone could comfortably accept. A French physicist named Louis de Broglie proposed that particles might also behave like waves. Not metaphorically, literally. Electrons possessed wavelengths. Their behavior could spread across space like ripples moving through water. Soon afterward came the famous double-slit experiment. Scientists fired electrons one at a time toward a barrier containing two narrow openings. If electrons were ordinary particles, they should pass through one slit or the other and create two simple bands on a screen behind the barrier. But that is not what happened. Instead, the electrons created an interference pattern, a wave pattern. Bright and dark bands appeared exactly as though each electron had passed through both slits simultaneously and interfered with itself like overlapping water ripples. Stranger still, if scientists tried observing which slit the electron passed through, the interference pattern vanished. The electron suddenly behaved like an ordinary particle again. Observation itself changed reality. Even now, nearly a century later, the experiment remains one of the most unsettling discoveries in all of science. The electron was not simply a particle or a wave. It existed somehow as both, or perhaps neither. Classical categories had broken apart completely. In 1926, Erwin Schrödinger introduced the mathematical framework that finally described this bizarre behavior. Instead of describing electrons as tiny objects following trajectories, his equations described probability waves. The electron no longer possessed a precise location before measurement. Instead, it existed as a cloud of possible positions spread across space. Only when measured did one possibility become real. This is the origin of the electron cloud. Not a physical mist surrounding the nucleus, but a map of probabilities. Regions where the electron might appear if observed. Some regions highly likely, others almost impossible. The atom transformed from a miniature solar system into something ghost-like and uncertain. A structure built from probabilities rather than solid objects. The familiar image of electrons orbiting nuclei like planets around stars quietly dissolved into abstraction. And yet, these invisible probability clouds determined everything. Chemistry, light, electricity, the behavior of stars. Even the existence of your own body depended on the strange quantum architecture hidden inside atoms. As physics descended deeper into matter, the universe became less mechanical and more dreamlike. Particles became possibilities. Matter became mostly emptiness shaped by invisible rules. And the electron, once imagined as a tiny sphere, began revealing itself as something far stranger than any human being had ever expected. The deeper physicists explored the electron, the more impossible it became to describe using ordinary language. It was not truly a particle in the familiar sense. It was not truly a wave either. Sometimes experiments revealed one nature, sometimes the other, and beneath both descriptions, something even stranger seemed to exist. A hidden layer of reality where certainty dissolved into probability. To understand why nothing in the universe truly touches, we first need to understand how electrons actually exist inside atoms. Because the atom is not a miniature machine. It is not a solar system. It is more like a strange standing pattern of possibilities suspended within invisible fields. In everyday life, the word orbit suggests motion along a clear path. Planets orbit stars. Moons orbit planets. A satellite traces a predictable route through space. But electrons do not orbit nuclei this way at all. In quantum mechanics, the old planetary image completely collapses. The electron has no definite trajectory between observations. Instead, it exists as a spread-out probability distribution surrounding the nucleus. These distributions are called orbitals. The distinction matters enormously. An orbit is a path. An orbital is a cloud of possibility. If you could somehow observe a hydrogen atom across millions upon millions of measurements, the electron would appear in different places each time. Over time, a pattern would emerge. A soft, blurry cloud surrounding the nucleus, denser in some regions, thinner in others, but never forming a hard boundary, never tracing a little circular path like a planet around a star. The simplest orbital is called the 1s orbital. It forms a nearly perfect sphere around the nucleus. The electron is most likely to appear close to the center, but there is no exact edge where the cloud stops. The probability simply fades gradually into space. Technically, the electron's wave function extends infinitely outward. In principle, there is a tiny chance of finding the electron astonishingly far away from its nucleus. The probability becomes unimaginably small, but never truly zero. Already the familiar idea of matter begins dissolving. If the electron has no hard surface and no exact location before measurement, then what exactly are atoms made of? Not little solid pieces stacked together. Not microscopic billiard balls. Matter is beginning to resemble patterns inside invisible fields rather than objects in the traditional sense. As scientists solved Schrödinger's equations for more complex atoms, the shapes of orbitals became increasingly beautiful and strange. Some resembled dumbbells stretching outward in opposite directions. Others formed four-lobed cloverleaf patterns. Others appeared like glowing rings surrounding elongated clouds. These shapes were not artistic inventions. They emerged directly from the mathematics of quantum mechanics itself. The geometry of reality hidden inside the atom. Every element in the periodic table owes its behavior to these orbitals. Carbon forms the foundation of life because of how its electrons arrange themselves inside specific quantum states. Oxygen behaves differently because its electron configuration differs. Gold reflects warm yellow light because relativistic effects alter the energies of its electron orbitals. The entire visible world emerges from these invisible quantum structures. Yet something else inside atoms proved equally important. A strange quantum property called spin. In ordinary language, spin suggests rotation. A spinning basketball, a rotating planet. But electron spin is not literal spinning. The electron has no confirmed size or surface to rotate, and yet experiments reveal that it possesses an intrinsic angular momentum behaving mathematically like rotation. Even stranger, electron spin comes in only two possibilities: spin up or spin down, nothing in between. This discovery led to one of the most important principles in all of physics, the Pauli exclusion principle. Proposed in 1925 by Wolfgang Pauli, the principle states that no two identical fermions can occupy the same quantum state simultaneously. Electrons belong to a category of particles called fermions. This means electrons resist being compressed into identical configurations. Inside atoms, only two electrons can occupy the same orbital, and they must possess opposite spins. Once those positions are filled, additional electrons must move into higher energy orbitals farther from the nucleus. This single rule shapes the architecture of matter itself. Without the exclusion principle, every electron in every atom would collapse into the lowest possible energy state. Chemistry would disappear. Atoms would lose their structure. The periodic table would not exist. Carbon would not form complex molecules. Stars would behave differently. Life itself would become impossible. The exclusion principle is one of the hidden rules that allows the universe to possess richness and complexity instead of collapsing into uniform simplicity. Imagine the quiet elegance of this. Everything around you exists because electrons refuse to share identical states. Your body, your heartbeat, the molecules inside your cells, the air drifting softly through a sleeping room, all depend on this invisible quantum law operating silently inside every atom. Yet the implications grow stranger still, because the exclusion principle does not only shape individual atoms, it also governs what happens when atoms approach one another. When two atoms come close, their electron clouds begin overlapping. The negatively charged electrons repel each other electromagnetically. At the same time, the exclusion principle prevents identical electrons from occupying the same states. Together, these effects create resistance, a barrier, a kind of quantum pressure that stops atoms from collapsing into one another. This pressure is what gives matter solidity. Not little hard surfaces touching, not particles colliding like grains of sand. The solidity of matter emerges from invisible fields resisting overlap. The chair beneath you feels solid because electron clouds repel the electron clouds inside your body. The floor supports your weight because quantum rules forbid atoms from passing freely through one another. Touch itself begins emerging not as contact, but as resistance between probability clouds and electromagnetic fields. Even now, resting quietly in the dark, your body is suspended above every surface by invisible quantum interactions happening at distances far smaller than human senses can perceive. And the deeper physics descends into this hidden world, the less reality resembles solid objects, and the more it resembles patterns, relationships, probabilities, and fields woven together in silence beneath ordinary experience. At human scales, the world feels stable and reassuringly solid. Stone resists pressure. Steel supports bridges. Mountains stand unmoving beneath drifting clouds for millions of years. Our senses evolved inside this illusion of solidity, and because the illusion works so reliably, it is difficult to imagine anything else beneath it. Yet inside every atom, beneath every surface, The universe behaves according to rules that seem almost detached from ordinary intuition. The closer science examined matter during the 20th century, the more reality resembled something fluid and ghost-like rather than mechanical and solid. By the 1940s, physicists had begun developing a framework even stranger than quantum mechanics alone. It became known as quantum field theory. And according to this picture, particles are not truly independent little objects at all. Instead, the entire universe is permeated by invisible fields extending through all of space. There is an electron field everywhere, a photon field everywhere, quark fields, neutrino fields, fields woven continuously throughout the cosmos like an invisible ocean filling reality itself. In this framework, what we call a particle is simply a localized vibration within one of these fields. An electron is not a tiny sphere moving through empty space. It is a small excitation of the electron field, a ripple, a disturbance, a temporary pattern emerging from something deeper and more continuous. Imagine the surface of a calm lake beneath moonlight. When the water is undisturbed, the surface appears smooth and silent. But if energy enters the system, ripples spread outward. The ripples are not separate objects existing independently from the lake. They are behaviors of the lake itself. Quantum field theory suggests particles behave similarly. Electrons are ripples within the electron field. Photons are ripples within the electromagnetic field. Matter itself becomes less object-like and more pattern-like. This changes everything about how we should think about physical reality. Your body is not made from tiny solid components packed tightly together. It is a vast arrangement of interacting quantum fields. The atoms inside your skin are mostly empty space structured by probability distributions. The electrons within them are field excitations without hard boundaries. Even the nucleus itself is built from quarks bound together through gluon fields operating deep inside the atomic core. Everywhere physics looks, solidity dissolves into interactions between invisible fields. And now we arrive at the central mystery. If electrons possess no hard surfaces, and atoms are mostly empty space, then what exactly happens when two objects seem to touch? Imagine lowering your hand slowly onto a wooden table. Long before the atoms inside your skin could ever approach the nuclei inside the wood, the outer electron clouds begin interacting. The negatively charged electrons inside your hand repel the negatively charged electrons inside the table through the electromagnetic force. At the same time, the Pauli exclusion principle prevents identical electrons from occupying identical quantum states. These two effects together create an invisible barrier, a region of intense resistance. As your hand presses downward, the repulsive electromagnetic force increases dramatically. The closer the electron clouds approach, the stronger the resistance becomes. Your nervous system detects this resistance and translates it into the sensation your brain calls touch. But the atoms themselves never truly meet. There is always a minute gap, tiny beyond imagination, but real. You can think of it almost like magnetic repulsion between two invisible surfaces suspended slightly apart. Except the actual physics is even stranger and more beautiful than magnets. What you feel as solidity is really electromagnetic pressure between quantum fields. Every sensation of physical contact you have ever experienced emerges from this invisible dance. The feeling of your feet against the floor, your hand resting against a pillow, raindrops touching your skin during a quiet evening storm. Even a hug between two human beings is ultimately electromagnetic interaction between electron clouds suspended impossibly close together without ever fully merging. Reality begins to resemble a universe where everything is held slightly apart by invisible quantum laws. The consequences become even more astonishing when we examine ordinary experiences more carefully. Consider sitting in a chair. It feels obvious that your body rests directly upon the surface. But at the atomic level, your body is actually suspended by electromagnetic repulsion. The electrons in the chair repel the electrons in your body strongly enough to counteract gravity. In a literal sense, you are hovering infinitesimally above the chair at all times. Or think about walking. Your feet never truly strike the ground. Instead, electromagnetic forces transfer momentum between the atoms in your shoes and the atoms in the floor. Every step becomes an interaction between invisible fields rather than solid contact between material surfaces. Even friction, which seems like the clearest evidence of surfaces scraping together, turns out to be electromagnetic. When two materials rub against each other, temporary electromagnetic attractions form and break constantly between atoms along their surfaces. These tiny interactions generate resistance and heat. What feels like grinding contact is actually a vast network of microscopic field interactions occurring billions of times each second. Temperature itself also emerges from atomic motion and electromagnetic transfer. Warmth is not a substance flowing through matter. It is the movement of energy between vibrating atoms and electron clouds. The warmth of sunlight on your skin. The coolness of stone beneath bare feet at night. The comfort of a blanket wrapped softly around your shoulders. All are electromagnetic conversations between matter and matter without physical touching in the classical sense. Yet perhaps the strangest realization is not that touch is an illusion, but that the illusion works so perfectly. Evolution shaped human senses to navigate survival at ordinary scales. We were never designed to perceive quantum fields directly. We perceive the useful approximation, solidity, texture, weight, pressure. These experiences are real in the sense that they consistently emerge from underlying physical laws. But beneath them lies a reality profoundly different from the one human intuition naturally imagines. And somewhere inside this revelation rests a quiet philosophical mystery. If every sensation we experience is ultimately an interpretation created by our brains from invisible field interactions, then the world we feel each day is not reality itself, but a translation of something deeper, something hidden beneath ordinary perception, something stranger, softer, and far more beautiful than solid matter alone. There is something quietly unsettling about realizing that every sensation you have ever trusted may be a carefully constructed interpretation rather than direct contact with reality itself. The table beneath your hands feels immediate, solid, unquestionably present. Yet beneath that certainty lies a hidden layer of quantum behavior so strange that even many physicists struggled to accept it when the evidence first appeared. Because the deeper science explored matter, the more it became clear that the universe is not made of tiny solid things touching one another. It is made of interactions, relationships, exchanges of energy between invisible fields extending through space. And perhaps nowhere is this stranger than inside the electromagnetic force itself. In everyday life, electromagnetism appears ordinary. It powers lights, creates magnets, produces lightning storms, holds atoms together. But quantum physics revealed that electromagnetism is not simply a smooth, invisible force filling space. At the deepest level, it behaves through tiny quantum exchanges. According to quantum electrodynamics, often called QED, electromagnetic interactions occur through the exchange of particles known as photons. Real photons carry light across the universe from distant stars. But another stranger category also exists: virtual photons. These virtual particles cannot be directly observed. They flicker briefly into existence during interactions between charged particles. When two electrons repel one another, the interaction can be described mathematically as a continual exchange of virtual photons through the electromagnetic field. This sounds abstract at first, but it is central to understanding why nothing physically touches. Imagine again your hand resting on a wooden surface. The electrons in your skin repel the electrons inside the table through countless electromagnetic interactions occurring continuously across unimaginably tiny distances. Virtual photons carry these interactions between particles. The resulting force pushes outward against your hand. Your nerves interpret the resistance as touch. Yet nowhere in this process do solid surfaces actually collide. Instead, quantum fields exchange energy through electromagnetic interactions mediated by virtual particles. This theory may sound dreamlike or philosophical, but it is among the most successful scientific frameworks ever created. The predictions of quantum electrodynamics match experimental measurements with astonishing accuracy. In some cases, the agreement extends beyond 10 decimal places. Few theories in human history have ever demonstrated such extraordinary precision. The invisible quantum world may seem strange, but it behaves according to mathematical rules of breathtaking consistency. And this strange hidden layer exists everywhere around you right now. Every object in your room, every breath you take, every sound drifting softly through the night depends on electromagnetic interactions between atoms. Even light itself is part of this conversation. When you look at an object, photons reflect from the electron clouds on its surface and enter your eyes. You never truly see the object itself. You perceive light interacting with its electrons. The visible world is already one step removed from direct physical reality. Color itself emerges from these interactions. A red apple appears red because its atoms absorb certain wavelengths of light while reflecting others toward your eyes. The redness does not exist objectively inside the apple. It exists as an experience created by your nervous system interpreting electromagnetic information. In this sense, reality as humans experience it is deeply relational. The universe presents signals. The brain translates them into sight, sound, texture, taste, and touch. But beneath those sensations lies a world far stranger than ordinary intuition suspects. Consider something as simple as a hug. Human beings experience physical closeness as comfort, warmth, and connection. Yet even in the tightest embrace, the atoms within two bodies never truly merge. Electron clouds repel one another long before atomic nuclei could ever approach direct contact. The warmth comes from infrared radiation and thermal energy transfer. The pressure comes from electromagnetic resistance. Every emotional experience attached to physical closeness emerges through invisible quantum interactions operating silently beneath awareness. Somehow this realization does not make human connection less meaningful. If anything, it makes existence more extraordinary. Conscious beings made from quantum fields have evolved the ability to experience tenderness, emotion, and beauty through interactions between invisible particles and forces. The universe learned how to feel itself through electromagnetic patterns inside living brains. Even your own thoughts arise through electrical signals moving between neurons. Tiny voltage changes travel across neural networks through ion channels controlled by electromagnetic interactions. Memory, emotion, imagination, dreams, all emerge from organized patterns of energy flowing through matter that itself is mostly empty space. A human brain appears solid and physical from the outside. Yet inside it exists a storm of atomic motion and electrical communication occurring continuously in darkness beneath conscious awareness. The realization becomes almost poetic. Stars forged carbon billions of years ago through nuclear fusion deep inside stellar cores. That carbon later became part of molecules. Those molecules eventually formed living cells. Those cells evolved into nervous systems capable of wondering what matter itself truly is. The universe became conscious enough to investigate its own hidden structure. And the answer it discovered was astonishing. Solid matter barely exists in the way humans once imagined. Everything is fields interacting with fields, quantum probabilities, vibrations, relationships suspended across invisible distances. Yet perhaps the strangest part is that despite this hidden complexity, the world remains reliable. Chairs still support weight. Stone still feels hard beneath fingertips. Water still flows softly across skin. The illusion works because the underlying laws operate with immense consistency. Electromagnetic repulsion always emerges when electron clouds approach. The Pauli exclusion principle always prevents identical fermions from collapsing into identical states. The quantum rules governing matter remain stable across the entire observable universe. And because of that stability, human beings evolved inside a world that feels beautifully ordinary despite being fundamentally strange. Reality hides its complexity behind familiar experience. A sleeping cat curled beside a window, rain tapping quietly against glass, the warmth of tea between your hands during a cold evening. Beneath all these moments lies a hidden choreography of quantum fields exchanging energy across tiny invisible gaps. Not touching, never truly touching, yet creating every sensation of touch you have ever known. The universe does not seem disturbed by this contradiction. It simply continues unfolding through elegant laws operating silently beneath perception. And perhaps that is one of the deepest mysteries of all. That a reality built from probabilities and invisible fields can produce a world that feels so immediate, intimate, and real to the conscious beings living inside it. By now, the familiar world has begun quietly dissolving beneath us. Tables no longer seem completely solid. Atoms no longer resemble tiny mechanical systems. Electrons have transformed into probability clouds and field excitations spread across space. And yet one profound mystery still lingers in the darkness. If matter is mostly empty space held together by invisible forces, why does the world feel so stable? Why can enormous structures exist at all? Why do mountains endure for millions of years instead of drifting apart like smoke? The answer lies partly inside one of the strangest consequences of quantum mechanics. A consequence so important that without it, stars, planets, chemistry, and life itself would collapse into impossibility. The Pauli exclusion principle does more than organize electrons inside atoms. It protects the structure of matter across the entire universe. To understand this, imagine for a moment a universe without the exclusion principle. Electrons would no longer resist occupying identical quantum states. Every electron inside every atom could collapse into the same lowest energy level near the nucleus. Atoms would shrink catastrophically. Chemistry would disappear. Matter would lose its familiar structure. The rich diversity of elements in the periodic table would vanish into something dense, unstable, and alien. The universe as humans know it could never exist. In our universe, however, electrons resist compression. They refuse to share identical states. This creates what physicists sometimes describe as degeneracy pressure, a kind of quantum resistance emerging not from ordinary forces, but from the mathematical structure of reality itself. This pressure is powerful enough to support entire stars against gravitational collapse. White dwarf stars are among the most extraordinary examples. These ancient stellar remnants form after medium-sized stars exhaust their nuclear fuel. Gravity begins crushing the dead star inward with unimaginable force. Under ordinary conditions, such compression should continue endlessly until matter collapses completely. But inside a white dwarf, electrons are squeezed so tightly together that the exclusion principle creates immense resistance. Electron degeneracy pressure pushes outward against gravity. The entire star survives because electrons refuse to occupy the same quantum states. Imagine that quietly for a moment. A dead star suspended against collapse by a quantum rule operating inside invisible electron clouds. A cosmic object roughly the size of Earth containing the mass of the Sun held stable by the strange mathematics of fermions. Quantum mechanics is not confined to laboratories or tiny particles. It shapes the architecture of galaxies and stars themselves. And if gravity becomes even stronger, as in massive collapsing stars, electrons eventually combine with protons to form neutrons. Then another form of degeneracy pressure emerges. Neutron degeneracy pressure. This supports neutron stars, objects so dense that a teaspoon of their material would weigh billions of tons on Earth. Again, matter survives because quantum particles resist occupying identical states. Even the life cycles of stars depend upon invisible quantum laws hidden inside subatomic matter. The universe is held together by principles human beings cannot directly see, only infer through mathematics and observation. Yet these same principles also shape ordinary experiences happening quietly around you tonight. Consider the simple act of lying in bed. The mattress beneath you supports your body because electromagnetic interactions resist compression between atoms. The fibers inside blankets remain soft because molecular bonds allow flexibility while still resisting collapse. The walls surrounding your room maintain their shape because quantum forces stabilize the arrangement of atoms inside solid materials. Every stable object in human civilization depends on the hidden architecture of quantum mechanics. Buildings, oceans, trees, human bones. Everything emerges from invisible fields obeying precise mathematical rules beneath perception. Even air itself reveals this hidden structure. At first glance, air seems empty and weightless. But the atmosphere is filled with constantly moving molecules colliding through electromagnetic interactions. When wind brushes gently against your skin, billions of nitrogen and oxygen molecules transfer momentum through microscopic field interactions. The softness of a breeze is actually an enormous network of atomic encounters occurring invisibly around you. The same is true for sound. A whisper drifting through darkness feels so immediate and natural that it is easy to forget what is actually happening. Vibrating air molecules create pressure waves traveling through the atmosphere. These waves reach your ears where tiny structures convert mechanical motion into electrical signals interpreted by your brain as sound. At every stage, electromagnetic interactions guide the process. Even music becomes a pattern of quantum interactions translated into conscious experience. Reality is layered with hidden conversations between matter and energy occurring constantly beyond direct awareness. Yet perhaps the most astonishing realization is not simply that touch is an illusion. It is that human beings evolved within this strange, invisible universe without ever needing to perceive its true structure directly. Evolution shaped senses for survival, not for objective understanding. Human perception simplifies reality into manageable experiences. Solid objects, definite surfaces, clear boundaries. But beneath these useful approximations lies a world where boundaries blur into probability clouds and interactions happen through invisible fields. In some sense, everyday reality resembles a translation rather than the thing itself. Your brain continuously constructs a coherent world from electromagnetic signals arriving through sight, hearing, touch, taste, and smell. It edits complexity into familiarity. It turns quantum uncertainty into practical certainty. You do not experience probability distributions when touching a wall. You experience solidity. You do not perceive virtual photons exchanged between atoms. You perceive pressure. Consciousness simplifies the universe into forms useful for living. And still, despite these simplifications, human curiosity eventually uncovered the hidden machinery beneath appearances. Tiny creatures living on a small planet around an ordinary star somehow discovered quantum fields, electron clouds, relativity, and the mathematical laws shaping the cosmos itself. That may be one of the strangest facts in existence. The universe evolved beings capable of uncovering the invisible principles governing their own reality. Beings capable of realizing that the world they experience directly is not the full story. Somewhere beneath every sensation lies a deeper structure woven from fields, probabilities, and quantum relationships extending across all of space. And as the night grows quieter around us, the ordinary world begins feeling almost magical again. Not because science destroyed mystery, but because it revealed a deeper one hidden beneath familiar experience all along. The solid earth beneath your feet, the warmth of another hand, the texture of rain against glass, the softness of blankets in darkness, all of it emerging from invisible quantum interactions between particles that never truly touch at all. There is an almost haunting beauty hidden inside the fact that the universe feels solid without ever truly becoming solid in the way human intuition once imagined. We move through a world of apparent surfaces and objects, yet beneath those appearances reality remains suspended within invisible interactions between fields and particles. Even now, while entire cities sleep beneath the night sky, Trillions upon trillions of quantum events unfold silently inside every object around you. Electrons repel one another. Photons exchange momentum. Atomic vibrations ripple through matter. Tiny probability clouds overlap and separate continuously without ever collapsing into classical contact. And somehow from all this hidden activity emerges the stable, ordinary world humans experience each day. The deeper physicists explored these mysteries, the more they realized that matter itself may not be the true foundation of reality. Instead, relationships appear fundamental. Interactions, exchanges, patterns of influence propagating through invisible fields. In some interpretations of modern physics, particles are secondary phenomena, temporary excitations emerging from something deeper beneath space-time itself. This realization began changing how scientists thought not only about matter, but about existence. Because if particles are simply localized disturbances in fields, then separation between objects becomes less absolute than it first appears. Everything in the universe exists embedded within overlapping fields extending infinitely across space. The electron field inside your body is not isolated from the electron field inside distant stars. It is part of the same continuous structure permeating the cosmos. In that sense, reality behaves less like isolated objects floating in emptiness and more like waves forming temporarily within a shared ocean. The boundaries humans perceive between things become softer upon closer inspection. Even the distinction between empty space and matter begins dissolving. Vacuum itself is not truly empty according to quantum field theory. Even in complete darkness devoid of particles, fields remain present. Tiny quantum fluctuations continue appearing and vanishing constantly. Virtual particles flicker briefly into existence before disappearing again. The vacuum seethes with hidden activity beneath apparent emptiness. Space itself possesses structure. This means the universe is never truly still. Absolute emptiness may not exist at all. Beneath silence there is always motion. Beneath darkness there is always fluctuation. Beneath the appearance of stable objects there is continuous quantum change unfolding invisibly every moment. And perhaps strangely, this hidden instability is exactly what allows reality to exist in its rich and dynamic form. Stars burn because quantum tunneling allows particles to overcome barriers they should not classically cross. Chemical reactions occur because electron clouds reorganize through quantum probabilities. Even sunlight reaching Earth depends on nuclear processes governed by subatomic interactions inside the sun's core. Every sunrise is powered by quantum mechanics operating 93 million miles away. The ordinary world rests upon invisible laws more subtle than human intuition ever suspected. Consider for a moment the atoms inside your own body. Most of them were forged long before Earth existed. Hydrogen emerged shortly after the Big Bang itself. Carbon formed later inside ancient stars through nuclear fusion. Oxygen, calcium, iron, and phosphorus were scattered into space when massive stars died in colossal supernova explosions billions of years ago. Eventually, these atoms drifted into new solar systems, new planets, new living organisms. The atoms inside your bones once existed inside exploding stars. The iron inside your blood was born in stellar furnaces before the Earth formed. Yet even these atoms are mostly empty space structured by invisible quantum fields. In a very literal sense, Conscious beings made from ancient stardust now sit quietly beneath the night sky wondering how matter itself truly works. And the answer turns out to be astonishingly strange. Not tiny solid pieces touching one another, but patterns suspended inside fields extending across the cosmos. The philosopher Bertrand Russell once remarked that physics tells us a great deal about how matter behaves, but very little about what matter ultimately is. Modern physics became extraordinarily successful at predicting interactions, probabilities, and relationships. Yet beneath the equations, the true nature of reality remains mysterious. What exactly is a quantum field? Why do particles possess the properties they do? Why does mathematics describe nature so effectively? Why should invisible probabilities collapse into definite experiences when measured? Even after centuries of scientific progress, the deepest questions remain open, and perhaps they always will. There is something humbling about this. Human beings often imagine science as a process gradually removing mystery from the universe. But in many ways, the opposite happened. Each discovery opened deeper mysteries beneath it. Newton explained planetary motion, but gravity itself remained mysterious. Einstein redefined gravity as the curvature of spacetime, yet spacetime itself became mysterious. Quantum mechanics explained atomic behavior while revealing a universe stranger than anyone imagined beforehand. The deeper we look, the more reality escapes simple description. And yet somehow this uncertainty makes existence feel richer rather than emptier. The universe becomes not less meaningful, but more wondrous. Because hidden beneath every ordinary moment lies an invisible depth humans rarely notice. A cup resting quietly on a bedside table contains oceans of empty space stabilized by electromagnetic fields. Moonlight entering through a window arrives as photons traveling across space from reflected sunlight. The softness of blankets against skin emerges from molecular structures resisting compression through quantum laws. Every ordinary experience becomes extraordinary once the hidden structure beneath it is revealed. Even sleep itself depends on these invisible processes. Neurons exchange electrical signals through ion channels embedded in cellular membranes. Molecules drift between synapses carrying information through electrochemical interactions. Tiny quantum rules operating inside atoms ultimately help generate dreams, memories, and consciousness itself. Somehow the universe arranged matter into forms capable of awareness. Forms capable of asking questions about their own existence while floating on a small planet beneath silent stars. And perhaps tonight, as the room around you grows quieter and your thoughts begin drifting more slowly, the world itself may feel slightly different than before. Softer, stranger, less mechanical, and more alive with hidden structure. Because beneath every sensation lies a deeper reality woven from invisible fields and quantum possibilities. A universe where nothing truly touches, yet everything remains connected through interactions unfolding endlessly across the silent fabric of space. As physics descended deeper into the hidden structure of matter, something unexpected began happening. The universe stopped resembling a machine built from tiny parts and started resembling something far more fluid and interconnected. Reality became less about objects and more about relationships. Less about solid things and more about patterns emerging from invisible fields. The old mechanical picture of existence slowly dissolved into something almost dreamlike beneath scientific observation. Yet strangely, this deeper understanding did not make the universe feel colder. If anything, it made existence more astonishing. Because once you realize that nothing truly touches, the ordinary world begins glowing with a different kind of wonder. Consider what it means for your body to exist at all. Right now, trillions of atoms are arranged into an extraordinarily delicate structure capable of awareness. Your bones hold shape through electromagnetic interactions between atoms. Your heartbeat depends on electrical signals propagating through specialized cells. Your thoughts emerge from vast networks of neurons exchanging electrochemical information through microscopic quantum processes. Every sensation you experience is generated through invisible field interactions occurring continuously inside matter that itself is mostly empty space. And yet, from this emptiness comes consciousness, emotion, memory, imagination. Somehow the universe arranged fields and particles into forms capable of feeling loneliness beneath stars and comfort beside warm light, capable of falling asleep while contemplating reality itself. Even more mysterious is the fact that consciousness experiences continuity despite being built from constantly changing matter. Most atoms inside your body will eventually be replaced over time through breathing, eating, drinking, and cellular renewal. The particles composing you drift in and out continuously, yet your sense of self persists, like a whirlpool maintaining its shape while different water flows endlessly through it. Identity may be more pattern than substance, more process than object. In this way, human beings resemble the quantum universe itself. Stable patterns emerging temporarily within deeper flows of energy and interaction. There is also something quietly beautiful about the realization that physical closeness has never depended on literal contact. Human connection remains meaningful even within a universe where particles never truly touch. A hand held gently during grief, a child resting safely against a parent, two people embracing after years apart. None of these moments become less real because they emerge through electromagnetic interactions rather than classical contact. The emotional reality remains profound. In fact, the hidden physics beneath these moments may make them more extraordinary. Invisible quantum laws operating across tiny distances allow conscious beings to experience love, warmth, and comfort. The universe learned how to create intimacy without physical touching at all. And perhaps this reflects something larger about reality itself. At the deepest level, connection may matter more than contact. Relationships more than boundaries. Interactions more than isolated objects. Modern physics increasingly suggests that separateness is not as absolute as human intuition once assumed. Every atom in your body originated inside ancient stars. Every breath exchanges molecules with the atmosphere surrounding the planet. Photons from distant galaxies pass silently through Earth every second. Gravity from remote stars subtly influences your body even now across unimaginable distances. Quantum fields extend continuously through all of space, connecting everything within the cosmos. The universe is not a collection of isolated things. It is an interconnected process unfolding everywhere at once. There is a strange comfort hidden inside that realization. Human beings often feel separate from the universe, as though consciousness exists apart from nature looking outward at reality from a distance. But physics tells a different story. You are not outside the universe observing it. You are one temporary expression of it, a pattern emerging from ancient cosmic processes still unfolding now. The atoms inside your body were forged in stellar furnaces. The energy powering your thoughts ultimately comes from sunlight born in nuclear reactions inside the sun. Your consciousness depends upon quantum fields extending throughout space-time itself. In a very literal sense, the universe became aware enough to contemplate its own hidden structure through you. And all of this emerged from particles that never truly touch. There is also humility in recognizing how limited ordinary perception really is. Human senses evolved for survival within a narrow range of scales. We cannot directly perceive atoms. We cannot feel electromagnetic fields consciously. We cannot sense quantum probabilities unfolding beneath matter. Yet despite these limitations, human curiosity uncovered invisible laws governing the cosmos with astonishing precision. Tiny creatures living briefly on a small planet somehow learned that reality beneath appearances is stranger than mythology ever imagined. Perhaps that is one of the most hopeful things about science. Not that it provides final answers, but that it reveals how much wonder still exists hidden beneath ordinary life. Every object around you contains invisible worlds. Every moment rests upon laws deeper than immediate perception. Even silence itself contains quantum fluctuations rippling invisibly through space. The universe remains mysterious no matter how much we discover. And maybe that mystery is not something to fear. Maybe it is something beautiful, something calming, because the cosmos does not require complete understanding in order to be meaningful. The stars burned long before human beings existed to study them. Oceans moved beneath moonlight long before consciousness evolved to admire them. Reality unfolded through elegant laws for billions of years before any living mind wondered what matter truly was. Tonight, as darkness settles softly around the earth, countless people sleep beneath skies filled with ancient starlight. Their bodies held together by electromagnetic fields and quantum rules they will never consciously notice. Their dreams drifting through brains built from atoms born inside dead stars. Their hands resting gently against pillows without ever truly touching them. And perhaps there is something peaceful about ending here. Not with certainty, but with wonder. The solid world around you has always been stranger than it first appeared. Matter is mostly emptiness shaped by invisible fields. Touch is electromagnetic resistance between probability clouds. Particles are excitations of deeper quantum structures extending across the cosmos. And still, despite all this hidden complexity, the universe remains breathtakingly beautiful. Quiet rain against windows, warm light in sleeping rooms, the distant glow of stars beyond the atmosphere. Conscious minds drifting slowly toward dreams inside a cosmos built from invisible relationships rather than solid certainty. Nothing truly touches. Yet somehow, against all odds, everything remains connected. Somewhere tonight, beyond the walls around you, beyond cities glowing softly beneath clouds, beyond oceans shifting under moonlight, the universe continues expanding silently through darkness older than human imagination can fully grasp. Galaxies drift apart across incomprehensible distances. Ancient starlight crosses billions of years before reaching waiting eyes on Earth. Inside stellar cores, atoms fuse together through quantum processes hidden beneath crushing gravity and impossible heat. And here, on one small planet orbiting one ordinary star, conscious beings lie awake wondering what reality itself truly is. Perhaps that is the most extraordinary part of this entire story. Not simply that matter is strange, but that matter became capable of questioning its own existence. The universe arranged itself into forms that could gaze upward and ask why anything exists at all. Yet the deeper science searched for answers, the more reality transformed into something softer and more mysterious than anyone expected. The world that once appeared solid became mostly empty space. Tiny particles became probability waves and quantum field excitations. Touch dissolved into electromagnetic resistance between invisible clouds of possibility. Certainty itself gave way to probabilities hidden beneath observation. And still the universe continued working perfectly. Stars still formed. Trees still grew quietly beneath sunlight. Human beings still loved, dreamed, feared, and wondered beneath the night sky. It is tempting sometimes to imagine that scientific discovery strips magic from existence. But perhaps the opposite is true. The old universe of tiny mechanical particles colliding like clockwork gears was ultimately smaller than the reality science actually uncovered. The true cosmos is stranger, more layered, more mysterious. Reality is woven from invisible fields extending through space-time. Empty space itself trembles with quantum fluctuations. Particles emerge temporarily from deeper structures humans still barely understand. And somewhere within this hidden architecture, consciousness appears like a brief light flickering awake inside the dark. Even time begins feeling different when viewed through this lens. Human lives seem long to us because we experience them moment by moment. But compared to cosmic scales, a century is less than an instant. Entire civilizations rise and vanish while stars continue burning overhead. The atoms composing your body existed long before your birth and will continue existing long after your final breath. Matter rearranges endlessly across time. The universe recycles itself continuously through stars, planets, oceans, atmospheres, and living creatures. In that sense, death itself becomes less absolute than it first appears. The patterns change. The particles remain. The atoms inside your body once belonged to ancient stars and forgotten worlds. Someday they will belong to something else again. Perhaps distant forests. Perhaps future oceans. Perhaps entirely new living beings beneath unfamiliar skies. Reality is movement, transformation, endless rearrangement of energy and matter through invisible laws unfolding silently across eternity. And throughout all these transformations, the quantum world remains quietly beneath everything. Electrons continue refusing identical states. Electromagnetic fields continue shaping matter. Probability waves continue governing particles hidden inside atoms. Even now, while you listen in the quiet darkness, countless invisible interactions sustain the ordinary world around you. Air molecules drift slowly through the room. Heat radiates softly from walls and blankets. Electrical signals move through your nervous system. Photons from distant lamps bounce gently across surfaces before entering your eyes. Every ordinary moment rests upon hidden quantum foundations operating continuously beneath awareness. There is something strangely comforting in that realization. The universe does not require human understanding in order to function beautifully. Quantum fields existed before consciousness evolved. Stars burned before minds existed to study fusion. Galaxies drifted through darkness before language arose to describe them. Reality simply unfolds according to elegant principles deeper than human perception. And yet somehow, within this vast ancient cosmos, moments of awareness still appear. Tiny islands of consciousness capable of experiencing wonder. Perhaps tonight you feel that wonder a little differently now. Perhaps the room around you no longer seems entirely ordinary. The walls, the floor, the blanket resting softly against your skin. Beneath their familiar appearance lies a hidden world of invisible forces and quantum relationships. A universe where particles never truly touch, yet everything remains connected through fields extending endlessly through space. The silence around you is not truly empty. It is filled with structure beyond direct perception. The stillness beneath matter contains constant motion hidden inside atoms and fields. And perhaps this strange hidden reality is not something cold or frightening at all. Perhaps it is beautiful precisely because it reveals how much depth exists beneath ordinary experience. Human beings spend much of life moving quickly through familiar routines without noticing the astonishing universe hidden beneath simple moments. But science, at its best, gently pulls back the curtain. It reminds us that existence itself is extraordinary. A warm cup held during rain, soft breathing in a darkened room, moonlight crossing a sleeping city, all of it resting upon invisible quantum laws older than Earth itself. And so, as this journey slowly comes to rest, perhaps the most important realization is not that touch is an illusion. It is that reality is richer than appearances. The world feels solid because invisible forces create stability with immense reliability. Human perception translates quantum interactions into experiences meaningful for conscious life. The illusion works beautifully, yet beneath it remains a deeper universe woven from probabilities, fields, and relationships extending across the cosmos. Nothing truly touches. Not atoms, not stars, not even your own hands resting quietly together in the dark. And still, despite that invisible separation, the universe somehow creates warmth, structure, beauty, memory, and connection. A cosmos of empty space and quantum fields became oceans, forests, galaxies, dreams, and living minds capable of contemplating the stars before slowly drifting into sleep beneath them. And perhaps that is enough. Perhaps wonder itself is the closest thing human beings ever come to touching the true nature of reality. Long before human beings understood atoms or quantum fields, people looked upward into the night sky and sensed that reality contained hidden depths beneath ordinary experience. Ancient civilizations imagined invisible realms behind the stars. Philosophers questioned whether the world perceived by the senses reflected ultimate truth or only appearances. Mystics spoke of hidden unity connecting all things beneath visible separation. They lacked particle accelerators and quantum equations, yet in a strange way, modern physics eventually returned to some of the same unsettling questions. What is reality beneath perception? What does it mean for objects to exist? Are the boundaries between things truly as solid as they appear? Science did not answer these questions with mythology or symbolism. It answered with mathematics, experiments, and astonishing precision. Yet the answers themselves became almost philosophical in their implications. The universe turned out to be less material and more relational than human intuition expected. Matter became patterns inside fields. Particles became probabilities until observed. Touch became electromagnetic interaction across tiny invisible gaps. And beneath all of it remained mystery, because even now, despite extraordinary scientific progress, physicists still do not fully understand why quantum mechanics works the way it does. The equations predict reality with breathtaking accuracy, yet the meaning beneath those equations remains debated. Some interpretations suggest every quantum possibility exists simultaneously across branching realities. Others suggest hidden variables beneath observation. Some propose consciousness itself may play a role in measurement. Still others argue the mathematics simply describes probabilities without revealing any deeper underlying mechanism. Even among the greatest scientific minds, the true nature of quantum reality remains uncertain. And perhaps that uncertainty is important. Human beings often hunger for final answers because certainty feels comforting. Yet the universe may not be built to satisfy human intuition. Reality existed for billions of years before minds evolved capable of questioning it. The cosmos owes us no simplicity, no obligation to appear reasonable according to everyday expectations. Instead, reality appears layered beyond direct comprehension. Each discovery reveals another horizon hidden beneath the previous one. Beneath molecules lie atoms. Beneath atoms lie quantum fields. Beneath quantum fields may lie something deeper still. Some physicists suspect space-time itself may not be fundamental. At the smallest scales imaginable, space and time might emerge from deeper quantum relationships humans have not yet fully uncovered. In certain modern theories, reality resembles an immense informational structure more than a physical machine. Geometry, energy, matter, and perhaps even time itself could arise from hidden quantum connections woven beneath space-time. The implications are staggering. The universe may be stranger than language itself can comfortably describe. Yet despite this immense complexity, human life unfolds mostly within simple moments. Warm sunlight through curtains, quiet conversations late at night, wind moving softly through trees, a sleeping city beneath rain. Perhaps this contrast is part of what makes existence beautiful. The hidden structure of reality is unimaginably deep, yet conscious life still experiences the world through tenderness, memory, emotion, and wonder. Quantum mechanics governs the atoms inside a violin, but music still moves the human heart. Electromagnetic fields create the sensation of touch, but comfort remains real when someone gently holds your hand. Science reveals mechanisms beneath experience without erasing the meaning of experience itself. If anything, understanding the hidden physics beneath ordinary life can make existence feel even more miraculous. Every simple moment becomes layered with invisible complexity. A candle flame dancing quietly in darkness depends on quantum transitions inside atoms releasing photons into space. Snow falling silently through cold night air forms intricate crystals because water molecules arrange themselves according to electromagnetic geometry. The smell of rain drifting through an open window emerges from tiny molecules entering receptors inside the nose and triggering electrical patterns in the brain. Reality becomes richer once its hidden depths are revealed. There is also something deeply humbling in realizing how temporary human existence truly is compared to cosmic time. Entire civilizations occupy less than an instant compared to the lifespan of galaxies. Stars lived and died before Earth formed. Countless species vanished before human beings appeared. Someday the sun itself will fade. Oceans will disappear. The earth will become silent beneath a dying sky. Yet even this impermanence contains strange beauty, because temporary things can still possess immense meaning. A single human life may be brief compared to cosmic history, but consciousness transforms fleeting moments into experiences of astonishing depth. Love, curiosity, awe, grief, hope. These emerge briefly within living minds before dissolving again into the larger universe from which they came. Perhaps consciousness itself is one of the cosmos's rarest and most beautiful phenomena. Tiny islands of awareness appearing briefly inside an ancient expanding universe built from invisible quantum fields. And tonight, somewhere within that immense cosmos you exist, listening quietly in the dark while ancient starlight crosses the universe beyond your walls. Your body held together by electromagnetic interactions. Your thoughts emerging from electrical patterns moving through neurons. Your sense of touch created by particles that never truly touch at all. Yet despite all this hidden strangeness, the world remains gentle enough for sleep. The laws governing reality continue silently whether humans understand them or not. Atoms hold together. Stars continue burning. Gravity keeps the earth turning beneath the night sky. And perhaps there is peace in realizing that mystery itself is not something to solve completely, but something to live within. A universe where nothing truly touches somehow still creates warmth, beauty, connection, and wonder. And as your thoughts drift more slowly now into the quiet darkness, perhaps the hidden quantum world no longer feels cold or distant, but strangely intimate. Because beneath every ordinary moment, the cosmos has always been whispering something extraordinary. And so, slowly we arrive at the quiet edge of the mystery, not with a final answer held neatly in our hands, because perhaps reality was never designed to fit comfortably inside human certainty. Instead, we arrive with something gentler, a deeper sense of wonder toward the hidden structure beneath ordinary existence. Tonight, we followed electrons into the strange architecture of atoms. We discovered that matter is mostly empty space. We discovered that particles behave like probabilities spread across invisible fields. We discovered that the sensation of touch itself emerges not from solid objects meeting, but from electromagnetic interactions and quantum rules operating silently beneath perception. Nothing truly touches, and yet somehow, from this invisible framework, the universe creates mountains, oceans, forests, stars, living creatures, and conscious minds capable of dreaming beneath the night sky. There is something profoundly beautiful about that. Human beings spend much of life surrounded by familiarity. Floors feel solid. Rain feels wet. Hands feel warm. The world appears stable and immediate. But beneath those familiar experiences lies an invisible reality far stranger than ancient mythology ever imagined. Every object around you right now is composed of atoms suspended through electromagnetic balance. Every sensation in your body arises from electrical signals traveling through neurons. Every breath moves trillions of molecules through empty space without a single atom ever truly making classical contact with another. And still the illusion works perfectly. Perfectly enough for love. Perfectly enough for memory. Perfectly enough for life itself. Perhaps that is what makes the universe feel almost poetic. Reality does not become less meaningful because its hidden structure is strange. It becomes more astonishing. The ordinary world reveals itself as an improbable miracle emerging continuously from invisible quantum laws. A candle flame flickering softly in darkness becomes a dance of excited electrons releasing photons. Snow settling silently onto rooftops becomes water molecules arranging themselves through electromagnetic geometry. Even the quiet rhythm of your heartbeat depends upon ions crossing cellular membranes through tiny electrical gradients inside living tissue. The cosmos is not only vast, it is intimate. Its deepest laws whisper through every ordinary moment of human life. Somewhere beyond the atmosphere tonight, stars continue burning through nuclear fusion. Inside their cores, hydrogen nuclei overcome electromagnetic repulsion through quantum tunneling and merge into helium, releasing light that may someday cross galaxies before reaching another distant world. The atoms inside your body were born from such stars long ago. Carbon from ancient stellar furnaces, oxygen from exploding supernovas, iron forged in dying suns before Earth itself existed. Your body is ancient matter temporarily arranged into awareness. A brief pattern of consciousness formed from particles and fields older than the planet beneath you. And perhaps the strangest thing of all is that this ancient cosmic matter became capable of asking questions about itself. The universe became aware enough to wonder what an electron truly is. A species evolved that could look beneath appearances and realize that solidity itself was an illusion created by invisible forces. Tiny conscious beings on a small blue world discovered quantum fields, relativity, and the hidden structure of matter while drifting through space around an ordinary star. That may be one of the most extraordinary stories the cosmos has ever produced. Yet for all the complexity hidden beneath reality, life itself still unfolds through simple experiences. Soft light through curtains before dawn, quiet conversations during sleepless nights, the comfort of blankets during rainstorms, the distant sound of wind moving through trees outside darkened windows. Human existence remains grounded in moments that feel small and personal, even while the universe behind them stretches across billions of light years and deeper layers of quantum mystery. Perhaps wisdom is not about escaping ordinary life for cosmic abstraction. Perhaps it is about seeing the extraordinary hidden quietly inside ordinary things. To recognize that beneath every touch lies electromagnetic interaction. Beneath every object lies empty space and probability. Beneath every living mind lies a universe of atoms forged in stars. And beneath all of it remains mystery. Not a frightening mystery, but a beautiful one. A reminder that reality is deeper than perception, stranger than intuition, more elegant than certainty. Tonight, as the Earth continues turning slowly beneath sleeping cities and drifting clouds, countless people rest without ever realizing the astonishing hidden structure supporting their existence. Their bodies suspended by quantum laws, their dreams emerging from electrical storms inside neural networks, their hands resting softly against pillows without truly touching them at all. And perhaps there is something peaceful in ending here, not with fear of the unknown, but with quiet awe, because the universe does not need to become simpler in order to become meaningful. It is enough that reality exists at all. Enough that consciousness appeared briefly within it. Enough that for a little while, beneath ancient stars and invisible quantum fields, We are here together wondering about the hidden nature of the cosmos before sleep slowly carries us back into darkness once again.